Okay, in last lecture we have gone through pattern recognition. What are the techniques are available for pattern recognition? What are the implementation methods that we can use for pattern recognition? One of few of them are template matching. Okay, statistical analysis, neural network. These are the important methods that are used for pattern recognition. Then what are the application of pattern recognition that we have gone through? Today, one of the important technique is the neural network. So we have to get into detail for neural network. What is neural network? How neural network build? What are the type of problems that we can solve by using neural network? So we have to go through all these things. So neural network means neural network is a technique which is the mathematical modeling of human brain, how human brain works, how neurons are interconnected in human brain. So that type of representation we use in neural network. There are different type of neural network that we can use. Either single layer neural network. Single layer means we have only one level of perceptron are there, and then output neurons. This is called single layer. For multi-layer, we have input layer and number of hidden layers are there, and then output layer. Then feed forward. Feed forward means the control signal travels in uh, the forward direction only. This is known as feed forward. In feed backward, we have a cycle. That means we have to give the input to the neural network, and then we test either the output is okay or not. Then we calculate the mean square error, or the error function is used to calculate, and then that error has to be feedback feedback, or we can say make the cycle up to the input neuron again and again. Okay, after some epoch or after some cycle we got the nearest value up to the expected result. Okay, so the we have to minimize the difference between actual result and expected result in this type of neural network. Okay, so that I have told you, the neural network has been mimicked. Okay, is the or the implementation of biological neuron in human brain. So first we have to get into the architecture of biological neuron. So in biological neuron, in a human brain, there are 10 to the power 10 number of neurons in human brain, and 10 to the power 14 are the interconnection between them. It is taking some time. Okay, wait, I'm trying to share the presentation and the notes with you. Okay. Okay. Okay, this is the architecture of biological neuron. Are you able to see that particular slide or the PDF file that I am sharing with you? आप लोग स्क्रीन देख पा
Yes,
रहे हो जो
sir.
मैं शेयर कर रहा हूँ?
Yes, sir.
Okay, so this is the architecture of biological neuron, where that in that particular a single neuron. This is the architecture of single neuron that is placed in the human brain, and the nervous system is the core system which is responsible for all the emotions, actions, and the understanding which uses by the human brain. So that type of architecture we try to mimic in the software or the hardware system in computer science, that is known as neural network. So that particular single neuron, when we implement the single neuron in artificial neural network, that is called perceptron. Okay, so like biological neuron, we have different parts of that biological neuron. Like these are the dendroids, the finger shape. They have the finger like shape. These are the dendroids which generate sensation and provide connection with different other neurons. These are the dendroids. Then the inner part of that particular neuron is called the soma or nucleus, we can say. Okay, that is the soma. Then the interconnection link between one neuron to another neuron is and the electrical signal pass through that particular channel, that is called axon, axon, axon. Then the synaptic are uh, they are same as dendroids, but the tip of the synaptic is dendroid, and the whole part that is used to connect from one neuron to another neuron, that is synaptic. Okay, or we can say synapse. So these are the description. First one is the cell body, or we can say soma. The body of neuron cell contain the nucleus. Okay, inner part of that is the nucleus of that particular cell body, or we can say soma, have the inner part that is called nucleus, that carries out biochemical transformation. Okay, biochemical transformation means for which input value or which input signal, which voltage has to be triggered, that has to be decided by that cell body. Okay, so this is the inner part of the biological neuron. Then dendroid, each neuron has fine hairs like tabular structure, that is an extension that we use around the cell body. These structures are called dendroids. Okay, they are used to accept the incoming signal. Dendroids are used to accept the incoming signal. Then we have axon. Axon is the link between one neuron to another neuron, and via that link we transfer the the signal, electronic signal, or we can say electronic voltage that is transformed from one neuron to another neuron in our human brain. Then we have synapse. Neurons are connected with the complex arrangement that is called synapse. The complex arrangement, which is interconnection of neurons, that has to be built by the synapse. Okay, so these are the components of biological neuron in human mind. Then after this, the artificial neural network that we use, the artificial neural network has that type of architecture where we have set of inputs. This is the first part of the artificial neural network. These are same as the soma or the cell body. These are the cell bodies. Then we have that arc, which is connected from input neurons to that bias, or we can say the summation function that we have, and the activation function. The arc or the edge is used as a synapse. Okay, that is the synapse. If we use multi-layer, then these synapses are interconnected with hidden layer of neural network. Okay, we are comparing the artificial neural network with biological neuron. Then these are the input layer, these are the snaps. Then this is the summation function. The summation function and the activation function means the functionality which placed inside the neuron or the nucleus of the neuron. These functionalities are placed in that particular place, and then we have to generate the output, same as we generate the output by using actuators of human body. Same, we in artificial neural network we generate the output after calculating the particular input, okay, based on the particular set of input. So this is the structure of artificial neural network and the single neuron architecture. If we have a single neuron and we are implementing the summation function, activation function, and then output, that type of system is called perceptron. Okay, remember that is the important term. So this type of configuration is called perceptron, where we have an input, and uh, weight factors are also there, available on the arc or the edges. And then after multiplying, the scalar multiplication we have to place there, like x1 into w1, x2 plus x2 into w2, like this the scalar multiplication we have to perform. Then after multiplication we have to perform the summation. Okay, then we have to implement an activation function on it, and then we will get the output. So this is the architecture which is known as perceptron. Okay, these are the components of neural network, where we have first layer is the input layer, then we have weight. Okay, in that particular architecture we have separately defined the weight. Normally we place that weight upon the that particular edge which connects the input neuron with the propagation function. Okay, after this we have propagation function, then we have threshold, that is also known as the activation function, and then output function. There is slightly difference between the threshold and activation function. We will discuss this on also. So the perceptron that is defined here, this architecture is the perceptron, is the typical made of three main mathematical operation. So when we make a perceptron or the architecture of neural network, then in that architecture we have basically three operations that we are going to perform. The first one is the scalar multiplication. The scalar multiplication is like x1 into w1, x2 into w2, x3 into w3, like this. Okay, this is the scalar multiplication. Then the summation. Okay, the summation means when we calculate the values of input neuron and the weight function at the point of propagation function, at that point we have to perform the summation. Like this we have defined here the summation function. So this is that at that point we have to perform the summation function, and after the summation function we will get the value as x1 into w1 plus x2 into w2 plus x3 into w3 plus xn into wn, like this. Okay, this is the summation function. Then the third operation that we perform, mathematical operation, that is the transformation. Okay, transformation using a distinct equation called activation function. So that is the transformation step where we perform the activation, or where we use the activation function. The activation function means the output which we are getting, a single value output that we are getting after performing scalar multiplication and summation. We have number of input values, we have number of weights. When we perform multiplication, scalar multiplication, then that particular edge will give a single value, that particular edge will give the single value, that particular edge will give the single value. After summation, the whole architecture will be converted into a single value, because we have performed the summation of the scalar multiplication. Then in activation function, the summation function, the output of the summation function has to be analyzed based on a threshold value. Okay, here we have the role of threshold. If we are getting the value like 5 and the threshold value is 3, okay, threshold value is 3, like this. If the value is greater than 3, then it will be treated as 1, and if the value is less than 3, that will be treated as 0. That is the threshold. Implementation of threshold is the activation. Okay, by which function we are implementing the threshold, that is known as activation function. So after implementing the activation function, we are getting the output. Okay, so in output also we have, it might be possible that the output of activation function could be passed through an output function to convert that output into a particular value, particular type of value that can be used. So this is the architecture or the component of neural network. So there are three mathematical operations. First one is scalar multiplication, second one is summation, and then third one is the transformation using distinct equations, that is called activation function. Okay, since the perceptron represent a single neuron in the human brain, that I have already told you, the architecture is called the perceptron, and the perceptron means a single neuron in human brain. How a single neuron works in human brain, that is the perceptron in artificial neural network. We can put together multiple or the many perceptron to represent the brain. If we want to mimic the brain or the to represent the functionality of human brain, then we have to use multiple perceptrons together, and that architecture is called neural network. Okay, when we have multiple perceptrons which are interconnected to represent the functionality of human brain, that is called neural network. This is the definition of neural network also. So these are the components. First one is the input, that is the x1, x2, x3 that we have marked. Then the weight factor, that is w1, w2. Then the propagation function that is used. That propagation function have implements the scalar multiplication and summation. Then the activation function. The activation function uh, triggers the value based on the threshold function, and then the output function. After implementing the activation function over the threshold value, we are getting the single value representation, and then that value has to be converted into the representable form by using output function. Okay, so these are the basic components of neural network. In detail, they have mentioned here. You have to go through these notes. I will forward you. In propagation function, they have mentioned there the simple summation of all the input to the is implemented in propagation function. Like we have I1, I2, In are the inputs, and W1, W2, W1 are the weights. After performing the summation over the scalar multiplication, we will get the result as I1 into W1 plus I2 into W2 plus I3 into W3 up to In into W1. Okay, and this will give a single number, because this is the mathematical calculation. After performing the mathematical calculation over the scalar multiplication and summation, we will get the single value. Okay, after performing the propagation function, then in the propagation function we implement the activation function. Okay, the activation function means, in activation function the summation can be compared with some threshold to determine the neural output. Okay, after performing the mathematical operation, we have to compare that value, the output value, with some threshold value, and then we will calculate the output of the neural network, or we can say the neural output we will get. This is called the activation function. Okay, after this, the threshold function, there are very slightly difference between the activation function and the threshold function. When a system is on at certain point, it's called the activation level. Okay, and the activation level has to be decided by the threshold. So the point when the system is on, that is called the activation level. As it is activated completely, this situation is called threshold, because the activation level has to be decided by the threshold. Okay, so these are interconnected with each other, the threshold value and the activation function. Okay, after this, the output function. The output function means we have to convert the input, or it might be possible that if we are using multiple perceptrons to create the neural network, then we will get at that point, after the activation function or in the threshold value, threshold function, we will get multiple outputs from every perceptron, because this is the architecture of perceptron. And for making a neural network, we are uh, combining multiple perceptrons together, and at that stage we have multiple neural output from every perceptron. Then these output has to be converted into the representable form by using output function. Okay, like if we have 15 output, or if we have used 15 perceptron for creative for solving a particular problem, then at that stage, after the activation function, from every perceptron we have 15 values. Every perceptron have a single value, and the total output are 15. And then for the output of neural network, we have to generate a single value. Then these 15 values has to be performed, or has to be gone through a particular mathematical function which will decide the output. The same type of operation that we perform in defuzzification also. We have number of set values as a output of fuzzy operation. Then for getting the output like crisp output, we have to perform the mathematical operation that is called defuzzification in fuzzy logic. Here we have number of methods in defuzzification, like center of gravity, mean, max, okay, mean of average, average of area. So these are the functions that we use in fuzzy logic. Same type of operation we have to perform in neural network also to get the representable output. Okay, this is the output function. So this is all about biological neuron and artificial neuron. Then what are the problems? Why neural network is popular after 2011? We have to get into this. Okay, so I have told, after to 1997, when IBM has introduced the Deep Blue game, which has defeated the world champion Gary Kasparov in the chess game. That was the first time when a computer has defeated a grandmaster in chess. After that success, the neural network has started in the artificial intelligence community to work with that particular system. But the problem was that time we have only single layer neural network that we are using at that time, and the single layer neural network is only efficient to solve the problem that are linearly separable. Okay, so the problems are, first one is linear separable problem. Okay, linear separable problem. Linear separable problem means the problem which have to solve that problem, if we divide the problem space or we plot the problem space in graphical method or in graph, then a single line, a single line to separate the output. Okay, to separate the different. And second one is non-linear. I will give you the examples for this. Like if we have uh, for that particular purpose, we have to get an example of AND operation. Okay, for in if we have the input value A and input value B, and after performing the AND operation A and B, then what will we got? The operation you already aware with it. For A we have the possible values like 0 0 1 and 1. Okay, these are the possible values for A, and then for B we have possible values are like 0 1 0 1. These are the possible values. After performing AND operation we will get the output as 0 for this, then 0 for this, 0 for this, and 1 for this. Okay, when we plot that particular output, okay, now we want to plot that output. We have to get into the next page. Okay, when you want to plot that output, you can linearly separate that output like this. Okay, this is the first structure that you are using. Then the x and y axis. Okay, you want to plot this like the x-axis define A and y-axis define B, values of A and B, and then when you plot these values, if that particular point denotes 0 0 or the origin or the 0 output, we can say if that is the 0 output value, here we have 0 output, and same if we are in uh, after this is the 1 for B, this is the 1 for A, that means that particular space denotes 1 1. Okay, this is the 1 and this is the 0. So if we plot these points, this is the origin 0 0, this is 1 for x-axis, this is 1 for y-axis. A is treated as x-axis, B is treated as y-axis. When we plot these output of the AND operation, then these three values are 0 0. That means we have 3 points here. We have 3 points here. These are the, this is the first 0 that we are getting, then second 0 and third 0. All these points will be 0, which will be plotted here. Okay, I just have shown this overlapped to show the output so that it will be visible. So this is the output of values, and this one is the output of one value. Okay, for that particular input 1 1 we have the output that is here, and for these three inputs we have the output here. For first first one, second one, and third one, a for A and B, after performing AND operation we are getting the 0 output we have placed here, and 1 output we have placed here. To show that output, to separate these output, we can use only a single line, that is like this. If we use that single line, that line is efficient to differentiate these two output space. A single line is efficient to separate these two output space. These are called linearly separable problems. Okay, where we have a single line and that single line is efficient to show the output value. Okay, this is called linearly separable problem. Then we have non-linear separable problem. The non-linear separable problem means if we the output space, or to distinguish the output space by using a single line, that is called non-linear separable problem. For that particular type of system, we have to get into the example, that is like this. If we want to have input like a and b, and we want to perform like XOR operation, okay, we want to perform XOR operation, then what we have to do, the output will be in XOR. What is the output of values? If we have both the values are same, then what will be the output? Any one of you? If we have values as 0 0 and 1 1, then output will be what? The output will be 0. We have to go through this. I think it might be 1 or 0, I don't have remember. But for example, like this, it provide output like this for similar values, either 0 or 1, or different values 1 or 0, like this type of output we can get either performing XOR or XNOR operation. We are getting these type of output values. So to plot these values, we have, if we have 0 0, that means that point we have value as 1. Okay, at that point we have value as 1. And for this point, if we have, sorry, we have value as 0. If we have input 0 0, then we have value as 0. And if we have value like 1 1, then we have value 0. But in between, if we have value 0 1, that means 0 and 1, that is here. Okay, this is the point here. In that point we are getting value 1. And for 1 and 0, that means 1 and 0, at that point also we are getting the value as 1. So this is the space which in that particular type of example, we cannot separate that output space by using single line. Okay, that single line is not efficient to place. If you place here, that means that is not efficient to draw this. If you place here, then it is not efficient to draw this. For these type of system, or so these type of problem are called non-linear separable problem, where a single linear line can to draw the output space. So for the solution of that space, we have to use two lines like this. Okay, in between these two lines we have the output as 1, and below the lines and above the lines we have output as 0. So these type of problem are called non-linear separable problem, where a single linear line is not efficient to draw the output space. Okay, these type of problems are non-linear separable problem. So uh, that is the most important question when you go through the neural network, drawing the neural network for problem solving. Then it might be complex to find how many number of layers you have to use, okay, or which type of neural network you have to use, because there are different type of neural networks, and every problem cannot be solved, or we cannot say that there is a universal neural network which will solve all the problems. We cannot say this. So you have to decide which type of neural network you have to use. So based on the problem space, we have to decide which type of neural network is efficient to solve the problem. Either the single layer or multi-layer neural network we have to use, either the feed forward or feed backward neural network we have to use. So which type of neural network we have to use, we have to decide by plotting the problem space. Okay, we have to plot the problem space, we have to analyze the problem, and then we can decide. So in that particular picture, the non-linear separable problem that we have taken, XOR operation, you can see this, we have two separate linear lines. That means that for that particular line we have to use a single layer, for that particular line we have to use a single layer. So for implementing the XOR operation, we have to use two layer neural network. Okay, for that, for solving that particular problem, we have to use two layer neural network, or we can say multi-layer. This is a type of multi-layer neural network where we have two layers. Okay, so if we solve the problem of AND operation or operation, then we have to use a single layer like this. And if we are solving XOR operation, XNOR operation, these type of problem which are non-linear separable, or we have to use two linear lines to separate the problem space, then we have to use non-linear separable neural network, or these are the non-linear separable problem, and we have to use two layer or multi-layer neural network. Okay, these are just linear lines, but in place of linear line, it might be possible that we could use different type of structure. Okay, like this. If we have that type of space where uh, this output is also 0, so which type of architecture we have to use? Then we have to use a single line over here that will separate one with all zeros. That can be possible if that output space is puzzled. Okay, like this is 1, this is 0, this is 0, this is 1, and the complex output space we have, then we can use other type of operations or other type of separable lines also. Like I will show you the sine wave, like the sigmoidal function that we can use, which will separate the space, or different type of functions that we can use. Okay, this is the example of linear and non-linear separable problem. Hope you are understanding all these things. What is the neural? Today we have gone through the neural network, then types of problem that we can solve by using neural network, either the linear separable or non-linear separable problem. You have to take the screenshot of all these things, or you can note down these things. Okay, there are two things I will repeat. The first one is this is the first one where we have non-linear we have two type of problems, either the linear separable or non-linear separable. For linear separable we have taken the example of AND operation, or you can take the example of OR operation also. So for this type of problem we can use a single line to separate the output space. So this type of problem can be solved by using a single layer neural network. Okay, then we have non-linear separable problem where we have used this type of neural network. Uh, Here we have two linear lines to draw the output space. This is the non-linear separable problem. This is one. Okay. Okay. If you want to draw the neural network, what you have to do? Uh, you have to just use architecture like this. This is the first neuron. This is the second neuron. We have two inputs A and B. This is the first neuron for A. This is the second neuron for B. Then we have to implement the weight over the arc. This will be the first, and then that will be the second. Okay, these two things are there. Then we have to use activation function here. Okay, propagation function that we have to use here. Then we have, after this we are using this, the after activation function, sorry, propagation function, the activation function we have to use, that will be the activation function. And after this we will get, sorry, we will put like this. Okay, so this is the architecture of single layer neural network, where we have to mention here, this is the x1 input 1, this is the x2 input 2. Here we have w1 weight 1, here we have w2, and then this is the summation function. After this we have to implement scalar multiplication here. So scalar multiplication will give us x1 into w1 as output, and that will give us x2 into w2 here. Okay, so after the scalar multiplication we are getting the summation. After implementing the summation we will get like this, x1 into x1 into w1, then plus x2 into w2, x2 into w2. Okay, that is what we can to show that particular this, like this. Okay, so this will the multiplication we have in that particular propagation function there are two operations. First we have to calculate the scalar multiplication from each input neuron by multiplying the value of input neuron with the weight factor, then we are getting the summation like this, and then we have to perform the activation function. Over here we can use any type of activation function, either step function we can use, okay, either sigmoidal function we can use, or different type of functions are there. Ramp is another function. Okay, so there are different type of functions that we can use. After performing these functions, we will get the output as y. This will be the output. Okay, so we have to adjust these values, like now we are going through the AND operation. For input value 0 0, we have the output as 0. Okay, so the if x has the input as 0 and x2 has input as 0, if we are taking weight factor as 1 and 1, then the scalar multiplication will be 0 and 0, and the summation will be 0, and the output will be as 0. So that is going to satisfy. Okay, if we are taking like this, if this is the 0 and 1, then if this is 0, this is 1, and these are 1 1, and after performing this, that will be the that will 0 and that will 1, and the summation will be 1. So this is not efficient because the output is not satisfying the second condition. So we have to adjust the weight according to this. Okay, so the weight could be, if you perform that operation by yourself, go through the search on Google, you will find the output. There are multiple output. It might be possible the multiple set of weight can satisfy the problem. So one of that example I am going to give you, that if input values are fixed, either 0 0 0 1 1 0 and 1 1. So we have to adjust weight like this: 0.4 and 0.4. These are the weights. Okay, then the bias value is 1, which we have to add. Here we can also use a bias value, that is we can use plus b. Okay, that we can also use, that is called the bias, to tune our output. The bias value is used to tune the output. So it might be you can take that value as 1. Okay, and for the output, the activation function, we are using step, and step function have the value if the output from that propagation value is greater than 1. Okay, if the output is greater than 1, that means it is equal to 1, otherwise it is 0. Okay, otherwise it is 0. So w1, we have got w1 as 0.4 and w2 as 0.4. Okay, then calculate these values. B equal to, now we have b equal to b equal to 1. Okay, b equal to 1, and the value have the threshold is 1.5 we can take, then it will be efficient. Okay, you can tune your system. Okay, now you have to provide the input set, and you will get the output as 1 and 0. Like if you have input as 0 and 0, then the multiplication will be 0 0, the summation will be 0, and the b value is 1, then the output from there we have 1. After performing the activation function, the threshold value 1, the output 1 is, that is output. Okay, the output 1 is less than 1.5, that means the value will be 0. Okay, because that is the less than 1.5, that means the output will be 0. So the condition is going to satisfy. Okay, then in next step, if we have 0 and 1, that scalar multiplication will be 0, the scalar multiplication will be 1, the summation is 0 plus 1 plus 1 plus, okay, sorry, that is not 1, that is 1 into 0.4, that is 0.4. Okay, so the output is 0 plus 0.4 plus 1, the output is 1.4, and 1.4 is less than 1.5, that means the output is 0, again 0, that is the second condition is also satisfying. Third condition will also satisfy, this is the same as first one, second one, and then the fourth one we have to test. If the values are 1 and 1, then the scalar multiplication will be 0.4 0.4, the summation will be 0.4 0.4 and 1, that means 1.8, and then 1.8 is greater than 1.5, that means the output is 1, and that satisfy the operation. So this is one of the example for linear separable problem. Same if we use non-linear separable problem, then we have to place if we go through the XOR operation, then that type of architecture we have to use. I will show you the output of that particular problem. I will send you through your WhatsApp. You have to go through it. If you are not output which is from there, then I will elaborate it another by in another lecture also. Just paste. For two-layer neural network, we have to use that type of system. Okay, this is the architecture that we have to use for XOR operation. That is the two-layer neural network where we have this and this. Okay, then it will be this will be the input x1. This will be the input x2. Okay, these neurons are x1 and x2. Then remember, this is the weight factor w1. Okay, this is going to be distorted. The diagram is going to. So this will be the w11. Then that particular edge which is mentioned here, that is going to be w12. Then this particular edge will be w21, and then this will be w22. Okay, like this. Here we have four weight factors. For this particular edge we have w11, for this particular edge w12, for that particular edge w21, that particular edge w22. Then here we have w3, and that will be w4. So we have now six weights are there. So we have six weights are there, and now we have to perform the operation. Now the input have to provide these inputs and tune these weight factors. Okay, now we have to tune these six weight factors to satisfy all the conditions of XOR operation. This is the multi-layer neural network which will satisfy that particular problem, that particular diagram. Okay, for solving that particular diagram, you can take the weight factor as 30, 10, 30, 10, and these will be the minus 10 and 20. And when you go through that diagram, you will get the similar output, or the exact output for XOR operation. I will provide the solution of that in your WhatsApp group. So remember, this is the architecture for we can say this is the architecture for, you have to just empty that place, or that will be changed. So this is the architecture for multi-layer neural network, or we can say two-layer neural network, to solve the XOR problem. Okay, so we have gone through the single layer, multi-layer, and different linear separable and non-linear separable problems today. Then the type of neural network that I have already told you, the notes I will send you, and you have to go through them. Okay, because due to the limitation of time. Okay, now I have to go to the attendance. तो जितने भी आप लोग आए हुए हैं, अटेंडेंस मार्क करने के लिए आप बताते रहिएगा. मैं आपके नाम यहाँ से ले रहा हूँ. ठीक है, तो इतनी चीज़ें आप एक बार देखिएगा. इसके नोट्स भी मैं आपको प्रोवाइड कर दूंगा. इनको एक बार देखिएगा जो मैंने आपको आज बताया है. अगर इसमें आपको कुछ भी प्रॉब्लम लगती है तो आप पूछिएगा. ठीक है, दैट इज़ वेरी इंपॉर्टेंट, बिकॉज नेक्स्ट ईयर आप लोग अब प्रोजेक्ट करेंगे, तो प्रोजेक्ट में आपने आप सिंपल जैसे नॉर्मल आपके सॉफ्टवेयर्स हैं, तो अब वो तो आपके साथ डील नहीं किया जाता बीटेक फाइनल ईयर या फिर एमसीए के साथ. उस जगह